Lesson 1.3 is titled Algebraic Expressions. The two objectives we have: to evaluate algebraic expressions and simplify them. The first thing that we're going to do is you're going to brainstorm individually a little bit and come up with as many words that suggest the same as the operations below. So you have addition, subtraction, multiplication, division. What other words would suggest the same thing? Go ahead and pause this video, take a minute to jot some words down, and then go ahead and hit resume to watch the rest of the video. Okay, so for addition, here's what I came up with, and you're welcome to have more than what I have, but increased by, more than, sum, plus, and added to. And then for subtraction, decreased by, minus, less than, the difference between, and fewer than. For multiplication, division, for multiplication, of, times, product, twice, or triple, etc. And then for division, ratio, quotient of, or per. And then I'd like you to add equal, and whenever you see the word is, you normally associate that with equal or equals. In problem 1, which algebraic expression models the word phrase 7 fewer than a number t? 7 fewer than a number t. So fewer than, right? That would indicate subtraction. So 7 fewer than a number t. Now this is, we're going to have to write this a little seemingly backwards. So you have to be careful with an example like this. So when you're dealing with subtraction, it's important to pay particular attention to how it's worded and not get not fall asleep and write the wrong answer. So 7 fewer than a number t. So we're actually going to write t minus 7. Okay, so that's the correct answer, so it's going to be C. So notice that, so it's 7 fewer than t. So here's t, but we want 7 fewer than that, so then we have to subtract 7 from it. Alright, so you would not do, it's easy to kind of just say, okay, 7 fewer than means subtraction, so 7 minus t. This would be incorrect. Alright, that would be t fewer than 7. Okay, and so we just get a little bit more practice. So what is the difference between 7 fewer than t and 7 minus t? So 7 fewer than t is going to be t minus 7. And then 7 minus t, you would write how it actually looks in that case. So that would be 7 minus t would be 7 minus t. Okay, those are two completely different expressions. In the next one, what's the difference between 7 less than t and t minus 7? So 7 less than t. So less than means the same thing as fewer than, means subtraction. So 7 less than t, so we're going to have to write t minus 7. Okay, so 7 less than t. So here's t, we subtract 7. Alright, and then t minus 7. Alright. It's the same exact thing. So 7 less than t and t minus 7 are the same. Alright, so there is no difference between those. Alright, and then we have 7 more than t and 7 plus t. So with addition, you don't have to be as careful. So 7 more than t, you can just write 7 plus t. And then, 7 plus t obviously can be written as 7 plus t. Right, so these are the same thing. So just a review, and I want you guys to be careful with subtraction. All right, it's important that when you're dealing with subtraction, you got to pay particular attention to the order. Okay, in example 2, very important example problem, because this is applied algebra 2 here. This is applying to real world situations here. You start with $20 and save $6 each week. What algebraic expression models the total amount that you save? And above this it says, to model a situation with an algebraic expression, do the following. The first thing it says is identify the actions that suggest operations. Okay, so you start with $20 and save $6 each week. All right, so I see the word save. All right, if you're saving something, would you be adding? So if you're saving money, you adding money or you subtracting money to your account, if you will? You would be adding. So save is a word that would mean addition. All right, so maybe you can go back and add that to your list. And each, whenever you see each, that usually represents multiplication. Okay, so we identified the actions that or the words that suggest the operations that we're using. That was the first step. The next step is define one or more variables to represent the unknowns. So what don't we know? We don't know the number of weeks. So W equals the number of weeks. All right, that can vary. All right, if you save for 1 week, you save for 2 weeks, you save for 3 weeks, that's going to be our variable. W will be our variable. And so that's a variable we're going to use to write our algebraic expression. So you start with $20. $20 is our constant. So we're going to write that down. We save $6 each week. So save means add. And then $6 each week. So 6 times, and then weeks is our W. So we're going to write 6W. All right, and then this is our algebraic expression. Okay, if we look at the got it problem, it says you had $150, but you are spending $2 each day. Right now, algebraic expression that models this situation. All right, so let's look at the keywords. So, all right, so you have 150, but we're spending. All right, so if you're spending money, how does that affect your bank account? Money's coming out, or you're losing money. So spending in this case would indicate we would be subtracting. Each, that's multiplication. All right, so those are our operations involved in this problem. So next is to define our variable. So the variable is going to be D, and that's going to equal the number of days. That's going to be our unknown. Are we going to be spending this amount of money? How many days? 1 day, 2 days, 3 days? That's our unknown. All right, so let's put it all together and write the expression to model this situation. So we start with 150. We're spending, so we're going to subtract. And we're going to subtract 2 times our variable D. So 150 minus 2D. All right, and that's our algebraic model. All right, in example problem 3, here we're evaluating algebraic expressions. So what we're doing here is merely substituting values in for our variables. So we have this we have this expression, and what we're going to do is we're going to plug -4 in for A and 5 in for B. So we're going to have 7 times -4 plus 4 plus 3B, or 3 times 5, minus 8. Okay, so I took -4 for A, and I plugged it in here, and I put B equals 5, so there's B, and I made the substitution. Okay, now if you remember your order of operations, you always want to do, please excuse my dear Aunt Sally, always do what's in parentheses first. So we're going to have 7 times -4 plus 4, that's in parentheses. -4 plus 4 is 0. And then plus 3 times 5 minus 8. Okay, so we took care of what's in parentheses. Now what we're going to do is we're going to multiply from left to right. Please excuse my dear Aunt Sally, so multiplication would be next. So 7 times 0 is 0, plus 3 times 5 is 15, minus 8. And now from left to right, we're gonna go ahead and solve. So 0 plus 15 is 15. 15 minus 8 is 7. All right, let's erase. And do the next one. All right, so we're going to plug in 1 for x. So we have 1 over 2 plus, plug in 1/2 for y. So 1/2 squared. All right. Please excuse the E stands for exponents. We can't do anything in parentheses. There's nothing to evaluate. The next, we shift our attention to the exponents. So 1/2 squared. So 1/2 squared is the same thing as saying 1/2 times 1/2. So that's going to give us 1/4. So we're going to have 1/2 plus 1/4. Now, what does that equal? Well, we need to get a common denominator. So if we look at 2 and 4, our common denominator is going to be 4. So 2 times what gives you 4? 2 times 2. So multiply the numerator by 2. So you're going to get 1 times 2 is 2. So 1/2 and 2/4 are the same thing. 4 times what gives you 4? 1. So you multiply that number 1 by 1 and you get 1. So it stays the same. Now since we have a common denominator, we can add across. So 2 plus 1 is 3. And then keep the common denominator, which is 4. So 3/4 is your answer for part B. Okay, in the got it problem for example 3, what is the value of the expression for x, or that particular expression, for x equals 6 and y equals -3? Alright, so let's plug in 6 and -3 for x and y. So we have 2 times, so x is equal to 6, so we have 6 squared, minus, now, very important, when you are plugging in a negative, always put it in parentheses. Okay, so when plugging in a negative, use parentheses. Super important. Alright, so it's 6 squared minus parentheses negative 3 squared. And then we're going to divide by 3. Okay? Alright, now our order of operations. Please excuse my dear Aunt Sally, so let's do what's in the parentheses first. So we have 2 and then times. So in parentheses we have 6 squared, which is 36. And then we have minus. So what is negative 3 squared? So negative 3 squared is negative 3 times negative 3. And what does that give you? That gives you 9. So we have 36 minus 9 divided by 3. So we have 2 times 36 minus 9. Let's plug that in. That's going to be 27. And then that's going to equal, so 2 times 27. That's going to give us 54. So 54 over 3. So 54 divided by 3. The final answer is 18. Okay, so super important when I plugged in the negative 3 for y, because what I was plugging in was a negative, I put it in parentheses. Okay, some quick vocabulary. This is review. An expression that is a number, a variable, or the product of a number and one or more variable is called a term. So in this example, negative 4x plus 7w minus 8, there are 3 terms. So negative 4x is a term, the positive 7w is a term, and the negative 8 is also a term. So there's 3 terms in that expression. The second vocab, coefficient, is the numerical factor of a term. So if we have 3x, the 3 is the coefficient. If we have negative 10y, what is the coefficient? Negative 10. And then the constant term is a term with no variables. So if we have 3x minus 7, the negative 7 is our constant. Like terms have the same variables raised to the same powers. So if we look here, 3x squared and positive 5x squared, those are like terms because their variables are raised to the same power. In the same way, 9y cubed z and negative 4y cubed z. Alright, so those are also like terms because their variables are raised to the same power. So we're going to use this in problem 5 to simplify algebraic expressions. So we want to combine like terms and write a simpler expression. So let's go through and let's circle all the x squareds. So we have a 7x squared and a negative 4x squared. And then we'll underline the y squareds. So positive 3y squared and a positive 2y squared. Alright, so combine the ones that are the same. So 7x squared minus 4x squared, that gives us a 3x squared. And then a 3y squared plus a 2y squared, that gives us a 5y squared. and that's your answer. For part B, let's do the same thing. We're going to have to distribute the negative first. So this is the distributive property, so we have to distribute the negative to the first and the second terms. So this is really a negative 1. That negative really is saying negative 1 times 3x. So negative 1 times, 3k. So negative 1 times 3k is negative 3k. A negative 1 times m is a negative m. Now let's distribute the 2 to both terms. So 2 times k is a positive 2k. 2 times negative 4m is a negative 8m. Alright, so let's combine like terms. Negative 3k and a positive 2k gives us a negative 1k. Now instead of writing negative 1k, we just write negative k. And then we have a negative m and a negative 8m. So a negative m is really saying negative 1m. So negative 1m minus 8m, that's going to give us a negative 9m. And that's the answer. Alright, we've finally reached our last slide, and we're going to combine like terms again. So in part A, let's highlight the j squareds here and here. So a negative 4j squared plus j squared. So what's negative 4 plus 1? That's negative 3. So we're going to have a negative 3j squared. Alright, so you're just adding the coefficients together. Remember, coefficients, that's one of our vocabulary words. And then we have negative 7k plus 5j. So you see both of these are different, they have different variables. So we cannot combine them. And we can't combine them to the j squareds. So we just bring them down and write them. And we are finished. So this is A. That's your final answer. Now for B, we're going to have to distribute again. So we're going to distribute this negative to both of these terms. So remember that negative is like saying negative 1. So negative 1 times 8a. That's going to give us a negative 8a. A negative 1 times 3b is a minus 3b. Plus that's probably premature to write that. So positive 10 times 2a. So positive 10 times 2, that's going to give us a positive 20a. And then 10 times negative 5b, that's negative 50b. Alright, so let's combine like terms. So we have a negative a squared and a negative a and a positive 20a. So that's a negative 8, a negative 8 and a positive 20. That's going to give us 12, positive 12, so positive 12a. A negative 3b and a negative 50b. So negative 3 minus 50, that's going to give us negative 53b. So notice I'm just adding and subtracting the coefficients together and keeping the variable. So here's your answer. Alright, thank you guys for sticking with me. I know that's a long section, so way to hang in there. And thanks again.